So, student measures the wavelength of these waves. Now, what he's done is he's measured the distance between the top of one wave and the top of another wave. He uses the ruler to measure the distance from one crest to the next crest. And it's asking you, how could he improve the method? So what they want you to say, and let's look at the mark scheme over here. If you measure more than one wavelength, and then you divide by the number of wavelengths. So if you measured 1 and then 2 and then 3, in fact, if you measured from there, or even from the beginning, look, you could measure all of those, and then you could divide by how many there are. So you can measure for 4 wavelengths and divide by 4, or 5 wavelengths and divide by 5. So that's what they wanted you to say. When you do that, you're going to average it out, and it's going to be a lot. You're going to get a much more accurate answer. So let's have a look at how many actual wavelengths there are. I'm going to go from the middle to the left. Middle to the left. So we got 1, 2, 3, 4, 5. All right. So there are 5 wavelengths. Let's say that I got a ruler and I measured 10 centimeters. Then the wavelength is going to be 2 centimeters, because it's going to be 10 divided by 5. So the wavelength, which is this symbol here, is 10 centimeters divided by 5, if that's 10 centimeters. And then I'd get the answer of 2. Now, if I tried to just measure 2 centimeters, I might not get it that accurate, because I could be off by half a millimeter or something like this. Or by a millimeter maybe. So it's very difficult to get it exactly right for smaller distances. Basically, measuring larger distances, you can get a much more accurate measurement than you can with a smaller distance. Okay.